Good afternoon.
Good afternoon.
Good afternoon.
All right, so let's see. Who we missing in St. John's? Is Aiden there?
Yeah, I'm
We're
here.
only
It's
missing.
Nathan.
Yeah, we're missing Nathan.
Oh, Nathan. Okay. All right. Okay, so Chloe, when I got your email yesterday, I didn't realize you'd wanted me to move up the time, and I had already set it up.
It's
And
okay.
So I'm like, oh, I got that. And then it wasn't until I got your email today that I went back and I'm like, oh crap, she wanted it 20 minutes earlier.
It's okay.
So-
It worked out.
All right.
Thank
well,
you.
good. All right. Well, sorry about that. But I'm glad it worked out. So, all right. Well, listen. Today we're going to do 5.5 and hopefully as much as 5.6 as we can. And I would love it if we could finish chapter 5 today, but I don't know if that's possible. So we'll just do what we can. We'll for sure do 5.5 anyway. So next week we're going to have, remember, a week from today is the final part 1, except for the Winslow girls. Okay? And, oh wait, Mogyan, didn't you guys want to do your final on Monday too, right? Both parts. So,
No,
So-
it was for the pre-calc.
oh, that's okay, sorry.
We can sit in this room for calculus, but we couldn't.
Okay, all right. I was just, 100 students and, anyway, I'm getting them all confused, but that's all right.
You're doing great.
We're good.
Thank
We're good.
you.
All right. So next, remember, a week from tomorrow, a week from today. All right. So part 1 of the final. Any questions about anything before we jump in today? All right. Well, okay, so let's start with 5.5. So the first thing we're doing is kind of reminding ourselves about the power rule in reverse, or what I've referred to as the anti-power rule. So when you're doing integrals, when you're doing the integral, what you do is you add 1 to the power and then divide by that new power. And then where we've had definite integrals, you plug in the number. Where you have an indefinite integral, it's plus c. Okay, so remember, because we've been doing indefinite integrals the last couple of sections, so now that we go back to the indefinite ones, remember you've got to put the plus c on the end. So that's the power rule in reverse, or the anti-power rule. All right? Now, but see, here's the problem. Here's the problem that we're going to run into, is as we get to more difficult problems, then let's say this one, okay? Then what happens is now you can't just sort of look at it and do it term by term, all right? So this is really the first integration technique. So other than just applying formulas, this is a technique, and I call it U substitution, all right? The book calls it substitution method, but I call it U substitution because what you do is anything that's raised to a power already, you substitute that whole thing for U. So you let U be 1 plus 3x squared, okay? Because that's what's raised to the power. Or if it's under a radical or whatever, that's what you pick to be U. All right, now, then you say, well, what's the derivative of U? What's the du? So you take the derivative. Well, the derivative of 1 is 0. The derivative of 3x squared is, in fact, 6x. And so then when you solve for the du by multiplying each side by dx, then you get du is 6x dx. So that's exactly what I've got right here, 6x dx. So I think somebody asked at one time, does the dx matter? And this is a situation in this section that dx is really going to matter because we have to have it to substitute. So the 6x dx, we're going to substitute in du. All right, so now we do the u substitution. So now the 1 plus 3x squared, we're going to make that u to the 1/3 and then du. And so the whole idea is now we have a simpler integral, then now we can apply the power rule to, the anti-power rule. So now this is going to be u to the 4/3 divided by 4/3. Here, let's put the plus c in that step too, because you actually get the plus c right from the beginning. So plus c. But then remember, dividing by 4/3 is the same as multiplying by 3/4. So you have 3/4 u to the 4/3 plus c. And now your last step is just to replace u with what we substituted in for u. So remember, u was 1 plus 3x squared. So we put that back in. So it's 3 times 1 plus 3x squared to the 4/3 over 4 plus c. And so that's the answer. All right, any questions on that? Now, before we do another example, I want to tell you a little story, and it's kind of illustrative about what we're doing, and if you go anywhere for help. There's sort of another approach to these problems, which I call the guess and check method, and I always hated guess and check methods. It just doesn't seem mathematical to me. But when I first started teaching at Holbrook High School, the teacher that had been there forever, that's the method that he used. And so I was helping his students, and I said, well, this is how I do it with the u substitution. And then the next day in class, he told the students, well, there are some teachers that use this lame method called u substitution, but you guys are too smart for that. So they come back and they tell me, and they're like, yeah, he kind of said you were stupid for doing this method. And then I said, well, which method did you understand? And they're like, the u substitution method. And then the highlight of my year probably is when this guy actually came to me that he didn't know how to do it, a complicated one, because his guess and check method wasn't working. And so, but the u substitution, this method really works. But I just kind of warn you that if you go to like Khan Academy or tutor.com, they might try this guess and check method, okay, which I don't really care for. All right, now, adjusting the integram by a constant. Sometimes in order to make the dx match, you must multiply by a constant. And so that's a legal thing to do, okay? All right, so let me show you what we're talking about here. All right, so see this part in parentheses that's raised to the power? We're going to let that be our u. So we're going to say, let's let u be 2 plus 4x squared. And then the derivative of that, well, again, the derivative of 2 is 0. The derivative of 4x squared is 8x. But see, and so that means, so our du is 8x dx, multiplying each side by dx. Well, guess what? I have an x dx, but I don't have an 8 dx to make it a du, and I have to make it a du. So then what I do is I multiply by an 8, and a 1/8 to compensate for it. So that now I'll have 8x dx. And so I can do the substitution. Okay? So let's go through it again here. Okay, so I've got my u to be whatever's in parentheses. And then the du, you take the derivative of it, dx. So then when you do the substitution, so you have 2 plus 4x squared to the 1/3. That's going to be your u to the 1/3. All right, then the 8x dx. So you only have x dx. I moved the x over here to be by the dx. But I need 8x dx. So I multiply by an 8 and a 1/8 to compensate for it. So now this becomes 1/8 u to the 1/3, and then this part becomes du. All right? So any questions on the substitution step? So that's really the new step here. Okay? Now you do the integration. Okay? So why don't I let you finish that one? So see if you can finish it off from there. All right, so Chloe, when you've got it.
I'm not sure what to do next.
Okay. Okay. So now you actually do, we've simplified it. See, this original thing is too complicated to do the antiderivative. But by doing this u substitution, now this is an integral that we can handle. So you just leave the 1/8 out front, and then you add 1 to this exponent. So 1/3 plus 1 is 4/3. And then you divide by 4/3, which is the same as multiplying by 3/4, and then plus c. Now you simplify the fraction in front. So that's 3/32, u to the 4/3 plus c. And then finally, you substitute back in terms of x what your u was, 2 plus 4x squared. And so you'll get 3/32 times 2/4x squared to the 4/3 plus c. All right, any questions on that? All right, so the substitution rule, the idea is that you substitute u equals whatever in terms of x. And then du is the derivative times dx to go from an integral in terms of x to a simpler integral in terms of u. Then you integrate with respect to u and then replace u back in terms of x, in terms of the function. Okay, anybody need more time on that?
Yeah.
Okay.
We're good, thank you.
Okay. All right. So now here, the stuff inside the parentheses is the argument of the trig function. That's okay. That's still what you want to pick to be u. Okay. So you typically it's whatever's in parentheses. So here I'm going to let u be 2 theta plus 4. Okay, then what would du be? What's the derivative of 2 theta plus 4?
Two.
2. Well, it's actually, so 2 d theta. So you can think of it as du d theta equals 2, and then multiply each side by d theta. Okay? So now, there's not a 2 with the d theta. So to put a 2 in there, what do we have to multiply out front to compensate for that?
1/2.
1/2. Okay? So we're going to have 1/2 and then a 2. All right, so now see if you can do the substitution and finish it off. Oops, that's the wrong one. All right, so Denon, when you've got it, or if you get stuck, let me know. All right, you need some help?
Yeah, I got stuck at after you find the antiderivative of that.
Okay, so when you do the u substitution, you get 1/2 sine u du. And then you say the antiderivative of sine is negative cosine. So it's going to be -1/2 cosine u plus c. And then you substitute back what u was, 2 theta plus 4, and that's your answer. Okay. So the idea of the u substitution is to take a difficult integral and make it a simpler one. Because the integral of sine u, we know how to do that. Okay? So that's the whole point of this. All right, let's do another one here. Okay, so using u substitution, we can verify the solution by taking the derivative. So just kind of keep that in mind whenever you're doing these on a quiz or a test. If you're not sure about your answer, just take the derivative and see if you get what you started with. Okay? All right, so let's see if you can do this one from scratch. Okay, so I'm not going to help you at all set it up. So you see if you can do this one. All right, so Rhett, what do you pick to be your u?
Just x to the fourth.
X to the fourth. All right, so then what would be your du? What's the derivative of x to the fourth?
4x cubed dx.
Yes. Okay. And so then what do you have to multiply by out front to get the 4x cubed dx?
1/4.
1/4. All right. So then you end up with that. All right. And what's the integral of cosine u?
Just
Sine
fine.
u.
Sine u, and then don't forget the plus c. So we have 1/4 sine u plus c. All right. And so then, Rhett, what's our final answer going to be?
Uh, 1/4 sine x to the fourth plus c.
That's it. Good job. And sometimes you might see the 1/4 written out front like that, or you might see it as a fraction. Those are both the same. Okay? All right, so this u substitution, this is an important thing that's going to come back to us next semester. We're going to use this again in chapter 8.
Mr. Strong,
Yes.
what happened to the x cubed in that problem?
The 4x cubed dx, do you understand how we got that?
Yeah, I see now.
So then the 4x cubed dx, all of that becomes du. Okay. All right. Other questions? Okay, so that's all we're going to do for 5-5. Okay. So we're going to go on to 5/6 now. Okay. Now, all right. So, actually, I'm going to skip that first little section of notes and just go right to the problem. Okay. All right. What I'm going to do here? See, this is the same problem that we did just a minute ago with U substitution. This is the first one that I did, where I let U be this and du was this. Okay. And so you can go through these and do them by U substitution. However, and so that's one way to do it. But in chapter 6, I'm really going to want to focus on doing difficult integrals with the calculator. So that's what I want to do here, okay? Is I want us to practice the rest of the period today on doing definite integrals with the calculator, okay? So let's just kind of watch me, or you can kind of follow along with me on this one. So I'm going to put this in the calculator. So that's math, and I think it was math, math 9 is function integral, okay? And so we've got limits of integration, 0, and then arrow up to 3. Okay, now this set of parentheses here is for the whole integrand. So what I need to do is sort of imagine that the parentheses that I'm given there are an extra set of parentheses, okay? Because I need to put the whole rest of it in together. All right, so I'm going to type in another set of parentheses, and then 1 plus 3x squared. Oh, whoops, I forgot the exponent. 3x squared. Okay, close that parentheses. And now I'm going to use the caret to raise all that to the 1 divided by 3 power. Okay, then I'm going to arrow down. I don't want to stay up in the exponent. Then open parentheses again, and then 6x, and then close that. And then the whole integrand is closed again with that set of parentheses. So that's like this red that I added. And then you write the dx. Okay? And then you press enter. So 63.018. Okay? And so if you look, that's what I ended up with. And this is, working it by hand here. Okay? But I just want to, like I said, I want us to practice with the calculator on this, okay? So let's have you do the practice 2. Oops, this one. So practice 2, I want you to do this. See if you can put that in the calculator correctly. Because it's a little tricky. It's a little tricky. Some people think, oh, working with the calculator always makes it easier, but All right, so Hannah W., when you've got it. Or if you
I
get
got
stuck.
I got negative 0.0207.
Negative 0.021 or 07 works. Okay, so just like a trick here, and so I'm really glad you got it with the sine to the fourth, because see, remember that's like sine 5x and then all in parentheses to the fourth. So sine 5x to the fourth. So you probably want to rewrite it like that when you put that in. Okay, but which you clearly did because you got the right answer. Okay. All right. So anybody not get negative 0.021 that doesn't understand that and would like me to put it in? Okay. All right. So now let's say we have, like we talked about problems where you have to find the area under the curve. This is this idea here is a very powerful idea when you're looking at the graph and you see symmetry. Because like in this one, let's say you wanted to find the area under the curve. See, it would probably be easier to do the integral from 0 to a and then double it. Okay? Because this is an even function. So when it's an even function, you just double the area from 0 to a. Now this is symmetric through the origin. So what kind of function is that? Odd. So what is going to be the... Well, let's just say this was the graph and I just wanted to find the integral. Not the area, but just the integral of this function. Can you see what the answer would be?
And multiply by 2.
Well, okay, now the area under the curve you would multiply by 2 when you calculated these separately. But let's just say I didn't need the area. But I had the graph and I just wanted the integral. The number. So the difference is, remember, the areas you have to take all the absolute values. So let's say I'm not doing that. I just want the integral from negative a to a.
0?
It would be 0 because, see, whatever this area is, this number here would be its opposite. So these would like cancel. And then same with here. So if you have an odd function when you graph it, okay, so this is what this is saying, okay? And so you actually do want to write that down in part 3. So if f is even, then the integral from negative a to a is 2 times the integral from 0 to a. So it's double. But if it's odd, the integral is going to go to 0. Because the area is, it's in a sense, this will be negative, a negative value, this will be a positive value. So now let me be clear, this is asking for the integral, not the area. But we're using the areas, we're using the graph to kind of simplify it a little bit. Now, you don't have to do that, especially in your calculator where you're plugging in numbers. You don't have to do that, but this is a good thing to learn. Okay, so like for this, if I'm just doing the integral, okay, I can look at the graph and tell if it's even or odd and see if that can help me. Or I could just plug it in just how it is. Okay? So you kind of decide how you want to do it. So either look at the graph and see if the symmetry can help you, or just plug it in how it is. All right, let's see. Nathan's not here. All right, so Hannah W., it's on you again.
I got 2.28 times 10 to the negative 13th.
Okay, so now let me help you understand why that answer means 0. Okay, so whatever you said, blah, 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 times 10 to the negative 13th. If you were to write that out, it would be 0.00000. You'd have 12 zeros, right? So when you rounded that to 4 decimals or 3 decimals, it would be 0. Does that make sense? So whenever you get an answer, see, the actual exact answer is 0. But what you're getting there, 2 point whatever times 10 to the negative 13, that's actually calculator error. So it's like, even though it's adding up, 100 rectangles, there's a little bit of error there when it computes the integrals. Not a whole lot. I mean, if it's times 10 to the negative 13, that's like, what, a quadrillionth? It's off. Okay, so it's not off by much, but it's actually 0. Now, so when you graph it, you can see like this part of the integral will be negative, this part will be positive. And so you can kind of go through and see, oh, this is going to be, it's like going to cancel. Now, if you just, this one's interesting because it's even, but the sum is still 0. But just putting it in, so it's 2 times this integral, which is 0. Okay. All right, so anyone have any trouble with the graph or putting it in the calculator or anything like that? Okay. All right. So next, I'm going to teach you how to find the area between 2 curves. Okay? And so basically, when you're doing your little rectangle heights, it's the top curve, the upper curve, minus the lower curve. So let's say this one is up at 3, and this one goes down to -1, then the height of this rectangle would be 3 minus a -1, or 4. So you take the top one minus the bottom one. So whenever you're asked to find the area between curves, you subtract, but you have to know which one's on top. So you have to graph these, okay? So this is the blank that goes in part 4. But really the thing that it doesn't really emphasize enough is that you have to know which function's on top. Otherwise you'll get the sign wrong. Which, then you'll know, oh, if I'm getting a negative area, that's a problem. All right, now on these I'm going to teach you yet another calculator trick. And this one is, I love this trick. Whoops, that's a little crazy. Okay, so this says find the area enclosed by the parabola y equals x squared minus 4 and the line y equals x. Okay, so go ahead and put those in your calculator for the y1 and the y2. Doesn't matter which. But just put those in the calculator so you can kind of see it. Okay? So now, when you graph this, okay, so let's see, wait, here we go. Oops. Okay. Okay, so the area enclosed, see, that's this little part, this little teardrop right here. And see, it doesn't really matter that part of it's above the x-axis and part of it's below, because the area is always going to be positive. So what you're going to do is to find these little heights, it's this top one minus the bottom one. Now, so which of these functions is on top? X squared minus 4 or y equals x?
Y equals X.
So y equals x. All right? And so that is that's going to be important. All right? Let's see. So what you need is so you're going to have so what you're going to have is the integral of x minus x squared minus 4 dx. That's what you're going to put in your calculator. And we're going to put an extra set of parentheses here. Now, here's the thing that's a little tricky on this, is that you have to have the limits of integration. So you've got to go from here to here for all your little rectangles. So how do you find those points? How do you find those x values?
You can do second calc and then press enter 3 times.
Yes. So second calc intersect. Okay? So if you do second calc intersect, you're going to find the two intersection points. And it's the x values that you're looking for. And so you might verify you get these two x values, negative 1.561 or 2.562. And so now you put that in your calculator. So to get the limits of integration for these, you have to find those intersection points. Okay? And so now this is the integral that you're going to put in there. Okay? All right, so go ahead and see if you can do that really quick. And I'm going to see if I can do it really quick. All right, I guess I'm gonna have to show a different trick. All right, Hannah W., what do you get for this one?
I got 11.682.
There you go. To the 1,000th. Bam. Good job. Right? So anyone have any trouble keying that in? Okay. So before class on Monday, if you would do practice 5, just kind of the same way. But here's the thing for practice 5 is that if the formula for a bounding curve changes at one or more points, you will need more than one integral. So let me show you visually. So when you graph these, you've got to know if you're going to need more than one integral. Okay? So like this, let's say if this is the area I'm trying to find. Well, if you imagine like a little rectangle here, it's the blue minus the x-axis. So it's just the blue. But a rectangle here, this height would be the blue minus the yellow. So you got to integrate this curve from 0 to 2, and then from 2 to 4, you would integrate the top one minus the bottom one. So you're going to have to graph these and just see. All right? But we'll pick it up from practice 5 on Monday, and then we're going to go into some of the formulas